Okay? And is this equation balanced?
No.
2HCl. Now note that calcium carbonate is not only found in limestone, but this is also the active ingredient in Tums and Rolaids. And what are Tums and Rolaids used for? This might be useful since spring break is coming up, so I'm sure you guys will upset stomach. Yes, you have an upset stomach, acid indigestion. You may want to neutralize that excess stomach acid by taking Tums or Rolaids, which contains calcium carbonate. So note that when you take calcium carbonate, that's going to produce CO2 gas. Now note that magnesium hydroxide, this is the active ingredient in milk of magnesia, which is another antacid. So note that these antacids are bases. Now, if you wanted to burp, which one would you take? Why would you take Tums? Yeah, because it's producing gas. Note also that Tums and Rolaids also are a source of calcium. So, when you get older, maybe you need to increase the amount of calcium that you intake because you're not drinking as much milk, because maybe you're lactose intolerant. So this is a source of, Tums and Rolaids is a source of calcium. So you can take Tums and Rolaids to make sure you have adequate calcium in your diet. Of course, if you like broccoli and other green leafy vegetables, then you can just eat broccoli. But now, if you've been following the Supreme Court healthcare debate, note that 26 states are saying, well, it's unconstitutional to mandate individual mandate for healthcare, because if the government can make people buy health insurance, they can make them eat broccoli.
It's the same thing.
So you're saying broccoli is the same as health?
That's what they're trying to say. Which doesn't mean the same.
Okay, let's go on to part C. 1 mole of magnesium hydroxide is dumped in 1 liter of water. Calculate the magnesium ion concentration in water, then calculate the pH of the solution. Then after that, we'll calculate the equilibrium constant for the following reaction. Okay, so how would you start part C? Okay, so 1 mole of magnesium hydroxide is dumped in 1 liter of water. Calculate the magnesium ion concentration in the water. So what's happening is that if you have, okay, so let's say we have 1 liter of water, and it says you add 1 mole of magnesium hydroxide solid to that water. Now, when you add the magnesium hydroxide into the water, what's going to happen? Yeah, so most of it will stay solid. So you'll have this magnesium hydroxide solid in the water. But note that based on this equation, some of it is going to dissolve. Okay, so you have a little bit of magnesium ion floating around and hydroxide ions floating around too. Now on the previous slide, we have the equilibrium constant for that reaction. So note that that's 1.5 times 10 to the minus 11. Okay, so for this reaction here, KSP. Okay, so KSP for this reaction. Okay, so have we done an equilibrium calculation before? Are you to the point where you can do an equilibrium calculation in your sleep?
No.
but you told me you know what to do. You said that. You said before we know how to set it up. So right here we put, initial. And then right underneath that we put air gas. And then right underneath that, equilibrium. So all you've got to do now is just fill in the blanks. Okay, so I'll start putting in some blanks, you can fill in the other blanks. Okay, so what goes into this blank here? Yeah, 1. And what are here? And then for the, what goes here? Yeah, so is X still your favorite variable?
Yes.
Okay. What about for magnesium ion? Is X your favorite variable because that's what your math teacher always uses? X? Is that one? What about for here?
2x.
Yeah, 2x. And at equilibrium, and here's going to be 2x. Okay, so now we can plug it into our equilibrium constant equation. So let me erase this part here. Okay, so we have KSP, which equals 1.5 times 10 to the minus 11. And that's equal to, so that's equal to the magnesium ion concentration times the OH minus concentration. And do we need to put anything else in there? No, because we have a coefficient of 2 here. Yeah, so we got to square that. So now that's equal to x times 2x squared. And now all that we've got to do is solve for x. So let's see, x times 2x squared is 4x cubed. So that's 4x cubed. And if we solve for x is equal to, let's see, that would be 1.5 times 10 minus 11 divided by 4. And that would be 1/3 power. 1.55. So x is 1.55 times 10 to the minus 4. Okay. So what is the pH of this solution then? Because we've got a little bit of hydroxide ion which has dissolved in the solution. So we got some hydroxide floating around in the solution. Yeah, so OH minus is going to be equal to, yes, that's equal to 2x or 2 times 1.55 times 10 to the minus 4, or that's equal to 3.10 times 10 to the minus 4. So how do you calculate pH? Okay, so let's see, pOH is equal to minus log of 3.10 times 10 to the minus 4, and that's equal to 3.5. So now pH is equal to 14 minus 3.5, and that's equal to 10.5. So although that magnesium hydroxide in Chem1A was inside the water, actually because it's slightly soluble, we'll get a basic solution out of that. So, if this is not a beautiful calculation, I don't know what it is. Now maybe we got a picture up here too. It's not as good as my other pictures, but I'm not making it. Okay, let's go on to the next question. Calculate the equilibrium constant K for the following reaction. Would you expect K to be big or small? So here's the reaction where we want to calculate the equilibrium constant K. So you said earlier that we can dissolve magnesium hydroxide in HCl. And this is also the same reaction which occurs in our stomach. So there's HCl in our stomach. This is stomach acid. Would you expect the equilibrium constant to be big or small? Now we know that magnesium hydroxide is not very soluble in water based on KSP, 1.5 times 10 minus 11. Would you expect the equilibrium constant for this reaction to be bigger than 1.5 times 10 to the minus 11?
Yes.
Okay, so is this, for this reaction, is K going to be greater than 1.5 times 10 to the minus 11? That is greater than KSP?
Yes.
It should be. You think this should be greater than 1? In other words, there's going to be more products than reactants.
Yes.
It should be, because you said that the HCl should dissolve the magnesium hydroxide, so this should be greater than 1. So how will we calculate the equilibrium constant K for this reaction? So if you were designing, if you're working for some company, you say, I'm going to design the next greatest antacid. And I've got to figure out, well, I want to make sure it works, so I've got to quantify my reaction. Okay, so to figure out the equilibrium constant K, let's do the following. Let's first write a net ionic equation that represents this reaction. So remember doing that way back in Chem1A? Net ionic equations? Yes, let's do that. Okay, so let me put this higher on the board. Okay, so I'll write this on the board again. Okay, so again, we want to write a net ionic equation. So in our ionic equation, do we want to break up magnesium hydroxide into ions? Do we want to break up HCl into ions? Why? Because it's, this is strong acid, so we break it up into 2H plus 2Cl minus. Do we want to break up MgCl2 into ions?
Yes.
And what ions do we break it up into? And 2Cl minus. And we want to break up water into ions. Why not? Because this is a weak, either weak acid or weak base. So we'll just keep it as